Well, welcome back to the final session of developing our DO sag curve, and the last part of the sag curve is really to go ahead and look at adding your UOD, your sediment oxygen demand. And so that's what this is going to be about, and we'll have a look at a couple of things. Just to correct a few errors that I had before. First of all, I think the reaeration coefficient over here, I think last time I had the reaeration coefficient looking at my river depth in foot instead of meters, and that messed the thing up. So my apologies, it should be this is the O'Connor-Dobbins equation here, and it looks at my river depth and my river velocity in terms of meters and meters per second rather than in meters. What does this mean in practice? Watch my KR. If I increase my depth from 9 to 10, you'll see my reaeration coefficient reduces substantially. If I decrease my depth from 8 to 8 from 10, you can see my reaeration coefficient, sorry, let me have a look at that, will go up substantially. So we're going to have our river depth at 9. I've just set it there mainly so that this DO curve can look elegant. Right now I have no sediment oxygen demand. If I do add sediment oxygen demand, you get this little relatively elegant curve over here. Another thing I noticed, and possibly was pointed out to me by one of you, is that my units for SOD in grams were in grams per cubic meter per day. That was an error. That's grams per meter squared per day. And then I also noticed that over here my river flow at mixing point, it was actually WWT flow. So I've just corrected that. And then finally, SOD in terms of grams per meter squared per day, I had that in meters cubed per day. So my error, and I apologize for that. So let's carry on over here. So once we've entered our SOD, and I'm going to just enter 1 over here, you'll see if I've got an SOD in terms of grams per meter squared per day, SOD in terms of my time step would be simply my SOD times my time step, which is there. And so you get, in this case, the time step is 0.1. So my SOD is going to be 1/10 times the cataloged SOD over here when we're looking at it on the basis of unit time. My area is actually equal to W times U, and I'm going to just quickly go ahead and correct these. That was another error that I noticed, and I forgot to correct that. So let's quickly do that. All right, so all we're doing is converting our area here. It is, first of all, the width of the river times the river velocity. So that's really saying it's the amount of area I'm covering, that little drop of water is covering in 1 second, or that front, if you like, that cross section of water is covering in 1 second. It is then converted to how much it's covering in 1 day. We're multiplying by 86,400 seconds per day, and then we're multiplying by 0.1 to get how much area it's covering in a time step. So that's fairly simple, and then we can convert that whole lot from grams per meter squared per delta time step to grams per delta time. So we're multiplying we're multiplying the SOD times the area covered in that time step to get the actual grams of sediment oxygen demand, i.e. how much DO is being demanded or consumed by the sediment in 1 delta time step, and that's then in terms of grams. And then what we can do is take those grams and convert that to a gram per cubic meter basis. In this case, we would then divide by the cubic meters of our WWTP and our river, and then remember we've got to multiply it by this factor B9, which is our time step, and the time step has to be in the denominator, so look at those brackets. So for an SOD of 1, you should have an SOD in terms of grams per meter cubed of per delta time of about well, it's basically going to be grams per meter cubed. So let's leave that out. My apologies again. That's what your SOD is going to look like. Now if we want to incorporate it, I'm just going to turn this to 0 again for effect. If we want to incorporate it into our system, our dissolved oxygen is equal to, as you remember, KDL, or is the previous day's DO. All right. Let's go back. Previous day's DO minus the oxygen consumed by the UOD load in the water, or the BOD load in the water. Then add the reaeration factor. So this is a function of my reaeration coefficient times the difference between DO and actual, DO actual and DO saturated. And then finally, you subtract your SOD from that whole lot, and that's the number you're going to get over there. So it's just calculating DO for the new time step. So if I put watch this curve over here. If I put a DO in here of, say, 1, let's go. I'm going to put a DO of 1. See what happens. A DO of 0 in this curve means that my reaeration really takes over as all the UOD is consumed in the system. When I put a DO, when I put a sediment oxygen demand of 1, you'll see you get this characteristic curve over here, and then it starts to recover. But you can see the recovery equilibrium is at about 6. I've just sort of manipulated these numbers so that the sag curve looks reasonably well behaved. Ideally, that sag curve should be in complete equilibrium, and I've not been able to do it. Now you're in a position to start playing around. You can add a wastewater treatment plant number of whatever, 10 million gallons per day, or 60 million grams per day, and then you can see what it's going to actually do to your sag curve. Okay, the last part that I wanted to sort of talk to you about actually was over here. Was part of the exercise was to look at the distance from my mixing point. We wanted to look at the distance from the mixing point. Well, that's fairly easy to calculate. If you know your time and you know your velocity, you can calculate your distance. And so that's basically what we've done. There's my river velocity in meters over 1 time step. And so I can calculate my distance either in kilometers or in meters. It doesn't matter. The other part is you also wanted to look at your UOD load. So that's concentration times flow. So here it is. That's my concentration, and I'm then multiplying it by my flow, and I'm just dividing by thousands to get kilograms per day. And you can also look at your DO, if you like, load, how much DO is being carried in the river at that time. And you can see that that's in kilograms per day as well. So this should go back to the go back to your the new terms of reference, and you should see the new values I give you. They're a little bit different, not that much, but just really designed to make the initial sag curve somewhat elegant and user-friendly. And then I think you're ready to go and play with your model and see what comes out of it. I hope you've had fun. I hope this has taught you a little bit. You've probably seen a few of my own mistakes, and that's just part of the process. So on with it now, and I look forward to seeing your final projects. Remember to write your final project up nicely. Well presented is half the battle. Please also, if you're unsure whether your sag curves are working, send them to me before you start doing your any of your playing around your sensitivity. Okay, good to talk. Good to have done this with you, and I wish you all the best.